Now see a formation of images by convex lens. Suppose you have taken a convex lens like this, and this line is principal axis which is passing through here optical center, that is C. Suppose here its focal length, that is f, and here we have taken that is 2f, and similarly this side it is f dash and this is your 2f dash. Here we do not take radius, we take f and 2f. Suppose object is placed somewhere here between the f and 2f. This object is AB. At least 2 rays are required from the top of the object to get image. Suppose you are taking one ray which is parallel to principal axis. After refraction it passes through focus. Another ray we take like this, which is passing through the optical center, and now these two rays are meeting at this point. So, the image is obtained over here. This is A dash and B dash. So, see here, when the object is between f and 2f, image is obtained beyond 2f dash. This image is here, see, that is a real inverted, but it is magnified also here. So, now whenever any ray is taken parallel to principal axis, after refraction it passes through focus. If it is passing through the optical center, it goes without any deviation, and if it is suppose vice versa of the first one, if the ray is passing through the focus, after refraction it becomes parallel to principal axis. Now, take another case where the image formed by convex lens is virtual, erect and highly magnified. See here, in this case we place the object between focus and optical center. Suppose this is lens, we are talking about only thin lenses. This is here C, here is suppose F, and object is placed over here like this AB. This side also I can take here F, approximately these are equal, F dash. Now, one ray we take parallel to principal axis, after refraction it passes through focus. One ray goes through the optical center like this. These are diverging here, these are not going to meet anywhere. So, we produce them here, and wherever they meet, the image is obtained at this point. This image is here A dash and B dash. So, this image is here, see, virtual, erect and highly magnified So, whenever you get you try to get the image virtual, erect and highly magnified, object should be placed between the focus and optical center. Now, see a formation of image by concave lens. Suppose you have taken a concave lens like this. In this case here, this is the principal axis C, here is F and here is somewhere we can take 2F. Whatever is the position of the object, suppose object is placed over here, one ray goes like this parallel to principal axis, after refraction it diverges, appears to be coming from focus. Another ray we take like this passing through optical center, it goes without any deviation. So, the image is obtained here, that is A dash and B dash if it is A and B. Now, this image is virtual, erect and diminished, and also one more important property about this, whatever is the position of the object, image is always obtained between C and F, whatever is the position of the object, and it is always virtual, erect and diminished.